Again, we're going to use two different methods for this, actually three if you include the calculator. I'm going to do method 2 this time, the one that involves the law of cosines, simply because the diagram that I've got showing here is conducive to that. So basically, here's the angle we're given. I believe it says south 40 degrees east. And this is the other angle we're given, which I believe is north 65 degrees east. And by the Z pattern, we should know that this angle in here is also 40 degrees. So the key here is that that whole angle is 105 degrees. That's kind of one of the tricks of doing these questions. So using the law of cosines, the magnitude squared is 250 squared plus 325 squared minus 2 times 250, 325, running out of room, cos 105. And you can do the square root of both sides, evaluate this all in one step, and we're going to get that r, the magnitude of r, sorry, is 458.5. And this is displacement, which is the vector form of distance, and it's in kilometers. Now, going back up to the diagram, we then need to find the direction. In other words, where is this headed? And to be honest, I didn't do a great job here because this diagram is somewhat deceiving. But I'm basically going to do, you know what, I can do it up here. I'm going to do sine theta over 325 equals sine 105 over 58.5. Theta equals, I'm going to go down, actually I'm going to go down here, theta equals inverse sine of 325 sine 105 over 458.3. And that's going to be, I believe, 43.2 degrees. Now remember, that's from this arm right there. And that arm is 40 degrees from due south. So this whole angle right there is 40 degrees plus our 43.2. So actually, it's going to be 83.2 there. Bottom line here is that we can say that vector r is 458.5 kilometers, and we can say from the south 83.2 degrees east. You could, if you wanted to, say from the east, that's going to be what, 6.8 degrees south. That's fine too. I'll write that down. Now, the other way of doing this is breaking each of the two vectors into their perpendicular components. So I'm going to draw this, and that's 250, and it goes this direction, which is the same as going down or south and east. And this angle in there is 40 degrees. The other one is going like this, this angle there is 65, that's like going north and east. Notice the first one is going south and east. This one's going north and east. Going to give you a hint here. North and south we will be subtracting, and the two that are going east we're going to be adding. And I'm going to show you a way of just a really simple way of writing this down. So this vector here, that's this side. I'm just going to say that that is, because it's the opposite side to angle 40, that's 250 sine of 40, which is 160.7. The part that's going down, the component going downward, is going to be, that's the adjacent side, so it's 250 times the cosine of 40, which is 191.5. This one up here, the part going east, this one here's 325. So it is 325 times, it's the opposite side, so sine of 65, which is going to be 294.6. The one that's going up, that's the side right there, that's the adjacent side, so it's equal to 325 times the cosine of 65, which is 137.4. Oops, not degrees. Now, we take this number and this number, and we wind up with this. We're going to add those two together because they're going in the same direction. And that's going to be 455.3. And then we're going to take this one, which is going down, combine it with this one, which is going up, which is going to result in 54.1 going down. This is the resultant here. Pythagorean theorem is going to tell us 455.3 squared plus 54.1 squared. And when we find the magnitude of that, we should get the same as we did before. We should get our 458.5 kilometers. For this angle, you know what? I'm going to go straight to this. I'm going to write down the angle is the inverse tan of the opposite over the adjacent. And I'm just going to do that in my calculator. Second function tan 54.1 divided by 455.3. And lo and behold, I get 6.8 degrees, which we've seen before because This angle in here was the 83.2, and we said we could also say that's the angle in there. So that gives us that angle, which is the angle we go down from east. Therefore, the vector is 458.5 kilometers, and it is east 6.8 degrees south, or from the south 83.2 degrees east.